We made this 14-minute video for an extra credit chemistry project, and it was watched in class. I'm not gonna lie, that's not the full truth. I'm not actually part of the school that this chemistry project was for, but I'm still in the same district. The biggest reaction was towards the end, so please stick to the end to see that. I worked hard on this, okay? But how on earth did I even get involved? Well, on April 2nd of this year, I was asked by a friend that went to this other school to go edit for their extra credit chemistry project with a Minecraft theme that was due on May 18th. But you may be asking, why would they even come to me? Now the reason for that is because they thought my editing was pretty damn good, and considering that I'm a Minecraft YouTuber, they thought I'd be great for editing it. On top of that, they wanted to make this extra credit chemistry project something to remember since it was towards the end of the school year. However, before I show you the video, I made what might be the worst decision ever. A normal person would probably use the same editor they've been using their entire life, but I'm not most people. I decided to learn DaVinci Resolve, something I've never used before, while editing the project I'm being paid for. Nonetheless, I was able to make it through with 2 very low sleep quality nights and turning in the final product at 2 a.m. Now, enjoy the video.
Oh, shift.
Run, get inside. He's destroying everything.
What the phosphorus is that thing?
The Bender Dragon. He came from the Bender dimension. He's starting to take away our fast pass. He's being powered by chemistry.
Then I'll fight him.
You can't. You gotta eat on your last mini exam. You don't even know how to do Boyle's Law.
Then where do I learn?
Monolith. They are our mentors there. If anyone can teach you how to stop him, they can.
Alright, I'm logging out for now. But when I respawn, you're getting nerfed. If the dragon's power came from chemistry, then I need to understand chemistry better than he did.
You made it.
But my villagers are gone.
You're a bum. What can you do? The Bender Dragon is not just a dragon. He's a chemistry-powered system. A Bender system.
And if you rush in without understanding the rest, you're cooked.
I'm good. I got an 8 on the last mini-exam.
That's absolutely terrible. You need to be like and get a 17 to defeat this dragon.
A lot of things matter for the final fight. Gas laws, carbon structures, combustion, tufa towers, acids. Are you ready for the challenge?
Nah, wait.
Too bad. Training starts now.
Why are there cows in the science lab?
This represents gas particles. Just watch. This is Boyle's law. When volume decreases, pressure increases, assuming the amount of gas and temperature stay the same. Pressure, volume, and temperature matter. The attacks of the Bender Dragon aren't random. They follow rules.
So I can predict them?
That's what I just said. Now temperature. When temperature increases, gas particles move faster.
Alright, smaller volume means more pressure. Higher temperature means faster particles. If pressure drops, gas can take up more space.
Yeah, now you're thinking like a Bender boy.
This looks atomic.
Obviously.
Who are you?
Name's Richard Buckminster Fuller.
Like the Buckyballs guy?
Am I really only known for balls?
Balls.
Bro, oh my god, you're actually a boron. I mean, moron. Whatever. Anyways, this is Buckminster fullerene, just one of the main allotropes of carbon. It's essentially a molecule shaped like a soccer ball, strong because of the way the carbon atoms are arranged.
So structure changes properties.
Yes, for example, atoms that bond in a specific crystal structure create diamonds, the hardest natural substance known. However, in a different structure, they can also form graphite, which is much softer and used in pencils. This armor demonstrates that concept. Diamonds are an allotrope of carbon, making this armor incredibly strong. Just take a look.
the Buckyballs lesson wasn't just random facts about carbon. The strength of this armor alone can be the difference between me winning and losing the battle. I am Steve. Holy moly!
These are tufa towers, calcium carbonate, natural mineral structures. In our version of Chemcraft, they matter more than scenery. Calcium chloride.
Can I drink this?
No,
Why not?
because it's mine. The sodium carbonate in the water reacts with the calcium chloride I poured in.
If tufa towers are made of CaCO3, where did the Na and the Cl2 go? Did they also make a tufa tower?
To be or not to be soluble, that is the question all about precipitation. Remember, never precipitate. Number 1, Na+ and all the other alkali metal compounds. Number 2, ammonium, NH4+ compounds. Number 3, nitrates, NO3+ and acetates, C2H3O3-.
Wait, so what you're saying is that Na and Cl2 are just spectating this reaction?
Looks like you know your stuff now, kid.
Thank you, Mono Lake Sensei.
Sorry, they told me to come here. I'm new.
Sorry, I forgot your name. Mr.
Burger. Hindenburger.
I'm sorry. Did he just say his last name is Burger? Oh my god, do you come with fries? Is your middle name Cheese? Huh? Oh, Burger. Yo, that's gonna explode, right?
Huh? I don't know.
That's not reassuring.
Hydrogen is highly flammable. When ignited in the presence of oxygen, the reaction releases a huge amount of energy very quickly.
Whoa. I mean, it's not like there'd be a random explosion in the sky. So like, it can't be that dangerous, right?
Exactly.
Okay, yeah. I definitely saw that one coming.
The Bender Dragon's fire is dangerous, because combustion is dangerous. If you understand what burns fast and how it spreads, you can avoid disaster or use it to your advantage.
Use it? How?
Think, Burger. I mean bigger.
If it stays airborne, then maybe the final hit shouldn't come from the ground.
Bro, just say what I'm supposed to do.
I want you to weaponize a hydrogen balloon.
Okay.
Hydrogen is highly flammable. When ignited in the presence of oxygen, you can get a combustion reaction. 2H2 plus 2O2 yields 2H2O. That reaction releases a lot of energy very quickly, about 286 kilojoules per mole of hydrogen.
That doesn't sound like a lot. Shish kebab.
Scale it up. Bigger. More balloons, more moles, more energy released. Boom! That's what brought down the Hindenburg in 1937. That's what can also bring down the Bender Dragon, but slightly more dangerous.
You want me to build one of those?
Steve, you gotta think bigger. If the dragon stays in the air the whole fight and his health keeps regenerating, the final hit probably can't come from the ground.
A hydrogen balloon. Target from the air. Get close enough. Ignite it.
Well, now you've got it, Bender boy.
Hydrogen is not something to mess around with. That was the whole point. The same reaction that made it dangerous could become the thing that finally ends the Bender Dragon.
Sit.
I'm not sitting in the dirt.
Then stand and be wrong. Your call. pH, potential of hydrogen. It measures the concentration of H+ ions in a solution. Scale goes from 0 to 14. The formula is pH equals negative log H+.
Okay.
If H+ is 0.01 molar, that's 10 to the power of negative 2. What's the pH?
2?
Correct. There might be some activation energy in you after all. Below 7 is acidic, above 7 is basic. Exactly 7 is neutral. Universal indicator. Color tells you pH without a calculator. Red means strongly acidic, low pH, high H+ concentration. Blue-purple means strongly basic. In the field, you won't be running calculations. You need to recognize what you're holding.
Wait, so what happens if you pour a strong acid on a tufa tower?
Now we're getting somewhere. Hydrochloric acid donates protons. The carbonate in the tufa accepts them. The solid CaCO3 dissolves. CO2 escapes as gas, and the structure falls apart. If the Bender crystals in the Bender dimension are mounted on tufa towers,
I can dissolve the base. Tower falls. Crystal hits the ground. Crystal loses power.
exactly. And for maximum reaction rate, you want a highly concentrated acid, H+ at least 1 molar, pH of 0.
What do I use?
HCl, strong acid, fully dissociates, clean reaction. I'll keep it short and basic.
I thought we were doing acids.
I walked right into that.
Dr. Kayfan was the only one who made me do actual math. And when it clicked, pH, concentration, the dissolving reaction, I realized that acid wasn't just a tool. It was the key to getting the crystals in the first place. Thank you, Mono Lake Sensei.
go. Pull up, break down the back door. Kunami, I hit a combo. This a trap, this ain't no chateau. Don't talk if you're trying to beef like taco. Keep the crocs locked on the feet. 22 years ain't hit my peak. Go ahead, son, make fun of me. Beat too loud, you got to speak up.
Gas laws, allotropes, tufa towers, flammability. At first, it felt like random stuff from different labs, but the more I trained, the more it's all coming to me. I am a bender boy.
Steve, you're ready for the Bender Dimension.
These open to the Bender portal. You'll need them to open the portal to the Bender Dimension, but first, you have to find it.
What do you mean?
What I mean is that there's a lake, Mono Lake, and in that lake, there's a tree, the chemistry. You know when you see it. Enter through the base, go underground, and the portal chamber is below.
Why does the bender portal connect from under a tree?
The Bender Dimension runs on the same chemistry that built these towers. Mono Lake and the Bender Dimension are linked. Same chemistry, different dimension.
The Bender Dragon already escaped the Bender Dimension once. If he ever escapes again, Chemcraft will surely collapse.
Good luck and don't disappoint us, like last time.
What do you mean by last time?
Oh, you don't know. The story goes way back. A great student of ours was trained just like you to defeat the Bender Dragon. He aced every mini-exam, getting constant 14s, 15s, and 16s.
So what happened?
Well, when we sent him on his journey, he started crashing out for no reason and died to fall damage. Was a pretty big disappointment. Anyways, you're our only hope. Good luck.
So long, Bender boy.
The village saw destruction. The mentor saw a chemistry problem. All I see is Bender. Pressure up. Open spaces are safer. Cool beans. Pressure dropped. More spread. Barometer was right. These attacks are based on gas behavior. But the fluorine? How is it constantly healing? That's it. Catalysts. The crystals are catalysts.
The speed of their regeneration was not a miracle. It was an acceleration. By pushing the healing reaction to its absolute limit, the target was not creating flesh from nothing. They were merely lowering the activation energy required for the process. At that moment, a fundamental truth became clear. Destroy the catalysts, and the reaction plummets to zero. Should the acceleration cease, even an immortal can be killed.
Let's see if Dr. Kafin was right or not. HCl. CaCO3 plus 2 HCl. Water, you know. Flaming arrow. Ooh yeah. If heat changes the structure enough, the catalyst stops working. Oh yeah, boy. Without catalysts, you're just a slower reaction. Bruh. Hydrogen plus oxygen. One spark, lots of energy. Let's hope class was right. Your huge exam, no extra credit. 2H2 plus O2 gives you 2H2O and 286 kilojoules per mole. Let's see if Hindenburger was right about scaling it up.
You did it!
The dragon is gone.
Yeah.
How?
Chemistry, 2 for towers, catalysts, flammability, gas laws, and the pH scale.
Huh?
I understood like half of that.
I am Steve.